All right, thanks guys for your patience. Any questions on FRQs from last night? I know you were able to check them. Any quick questions on FRQs or the evens? If you guys tried the evens, anything you want to ask? Yeah, Ellen.
The first one, letter C.
Okay, the first
It's
part.
not like one part of it, so it's not the whole thing.
Okay. Ready.
On number 9, I forgot how to use the plus C.
Okay.
Oh.
Yeah.
And then for response 1B, I forgot it.
B, 30.
B, as in part.
Bridget, what did you say? Which one were you looking for? C and D. Okay. Anything else, guys, from the FRQs?
On FRQ 3, letter B.
B. Okay, guys, remember, if you're just bored, you should not be just chatting it up. You should be working on the areas and volumes, right? Why not? Get ahead. Oh.
FRQ 3, letter C.
No, come back. Letter C, right?
Yeah.
All right, we're going back to number 9 real quickly. Did we not get to finish that yesterday? We might not have. Oh, we might not have. Sorry. I was remembering period 6 because our computer went weird and funny yesterday. Here we go. Number 9. Oh, yeah. Remember I made the big, huge deal about how the points count? And how, yes, there are 34, 36, 33, 32, whatever points in the one category for your AP exam score. But once you get past the one category, 9 points could make all the difference, bumping you from a 2 to a 3, a 3 to the 4, a 4 to the 5, depending on where you fall in that range. 9 points can make all the difference. And differential equations, if there is a find the particular solution to a differential equation with a clue question that's worth 5 to 6 to 7 to 8 points. Big deal. It's a big deal. What did I say yesterday as far as how to start? I know it's not in our notes, so it's a quick recap, but how do we always start solving a differential equation for y when they ask us to? Brandon?
Multiply by dx.
Multiply by dx. I'm trying to keep you guys a point of reference because I'm hoping, I'm praying if you multiply by dx, you're like, oh, that's right. Take the integral of both sides. But who does not belong? Y minus 3. So algebra tells us if we multiply by the reciprocal, we can get rid of that y minus 3. What we do to one side, we do to the other. Now what can we do to both sides? We can integrate. Remember that x is in the denominator. When we integrate both sides, you have to think about them separately, but so far at least you're going to start getting points. If you weren't able to get here, you get no points out of the 5, 6, 7, or 8. You have to be able to start. But now, hopefully you can get another point just by knowing ln absolute value of x. Hopefully another point just by considering the constant of integration plus c. Hopefully another point for knowing how to do the left-hand side. Now I'm doing u sub just to be safe. This one ends up being no big dealio, the integral of 1 over u du. There's no extra constant or anything, so we can go straight to ln of y minus 3. Remember, we always have to consider the u du whenever we have u sub. Our composition of functions. Question. We have 2 routes we can now take. One of them is, let's plug in right now, going back to our clue that's up here above. Let's plug in right now and find C. That's a horrible hopper, but you get the idea. Let's plug in right now and find C, then get y by itself, or get y by itself, then find C. What do you guys want to do? Okay, get y by itself. How do I undo ln?
E.
When I do e to an addition in the exponent, how do I split up or simplify this exponent? Yep. Remember, I have e to the times e to the c, and that can become a new arbitrary constant c, e to the ln of absolute value. Wait, e to the ln, what can I do to that? Those are inverses of each other, so I could just write e to the ln cancel out, absolute value of x. Over here, I have absolute value of y minus 3. Now, at this point, technically, If we wanted to be super mathy, we could start thinking about domain restrictions, because whenever you undo an absolute value, you have to think about plus or minus variations, plus or minus possibilities, depending on domains. But we're just going to kind of simplify the process for sake of this is just a multiple choice question.
Also, I think the x is greater than 0 for that first.
Oh, nice. I didn't even see that. Thanks, Brandon. X must be greater than 0, so we don't have to think about plus or minus x. We can just go ahead and say, okay, it's just a positive staying a positive. And on the left-hand side, we could also, to get rid of this absolute value, think about a range restriction with y, but we can take out the absolute value, say that c can be a positive or negative depending on the situation. Speaking of depending on the situation, let's get y by itself and let's plug in this situation, which would be, let's see, add 3 to the other side. Okay, it's time to plug in, find that c. We're almost done. We have the 0.11. Plugging in, that goes ahead and gives us 1 equals c times 1 plus 3. Long story short, c equals -2. Right? Subtract the 3. At that point, we can go ahead and plug back in y equals -2x plus 3. You guys double check me, but I believe the correct answer should be letter A.
Yeah.
Good. They wrote it a little differently, but it's the same thing. Now let's go look at those FRQs real fast and see where we got stuck. Time and time again, you guys like to think that you don't know how to take the second derivative given the first derivative, but we do. To find the second derivative, you just need to take d dx of this whole first derivative. So 3x over y is our derivative. We're going to go ahead and say, all right, it's time to take the derivative of the first derivative. In order to do that, we're going to have to, first of all, know that the derivative of the first derivative is the second derivative. And how do I take the derivative of this side? Quotient rule, good. Bottom d top minus top d bottom. So I have bottom d top minus top d bottom. All over bottom squared. That is not the final answer. They're telling us what our final answer looks like. It doesn't have to be simplified, but I do have to have only x's and y's. Who needs to get substituted for? dy dx. Who am I going to plug in for him? 3x over y. So I can go ahead and finish off my problem by, if I want to, I can make it a little bit prettier, but guys, you don't have to make it pretty, you just have to make it right. Plug in your 3x over y and then stop and say, I found it. And I don't have to simplify and make it wrong. Stop. You got it. There are x's and y's and constants in the operations. You're done. Letter C is very similar to number 9 that we just did, so I'm not going to spend a lot of time on it. Long story short, we got to multiply dx to the other side, and when we do, who does not belong? The y, so get rid of them. Then I can go ahead and take the integral of y dy. Now I'm getting points. Let's rack them in. We want all the points we can get. We'll get 1/2 y squared. We'll have 3/2 x squared plus c. Don't forget your plus c. Don't forget your plus c. That was pitiful. Sorry, didn't mean to be that pitiful. We can solve for y if you want. We would multiply everybody by 2. 2 times c is a new arbitrary constant. But I do multiply it there. The 2 cancels. 2 times c is a new arbitrary constant c. Plus or minus square root. Now it's time for me to plug in my, did they give it to me? Yeah, they did, and they always will. They're asking you to solve, they'll give you a clue. Go plug them in. So such that we have the point 0, -1. We have -1 is equal to plus or minus square root of 3 0 squared plus c. Question. which square root am I going to choose if I need it to equal a negative number? Exactly. Right here, I make the decision. Even though plus or minus is possible, for this clue, I am choosing the minus. For this clue, I am choosing the minus, which means back here, choose the negative square root. That is the proper one given this clue, given this domain. Then I can go ahead and continue solving. Dividing by a negative, I have 1 is equal to the square root of c. Square both sides, c is equal to 1. At the end of the day, I have y equals negative square root of 3x squared plus 1. You guys agree? Alan?
For the clue, if you're given h of something equals 0, how would you know whether to choose positive or negative square root? Like if you were to be
No, I see what you mean. You wouldn't be able to. It'd be an in-between, so you could say plus or minus, but they won't, for that very reason, they won't give you that clue. Yeah, they won't give you that clue. Last but not least, someone help me out. Letter D, there's a very particular forever card that you need in order to, at one point, with only 1 point, with the inability to make a sign chart and test more than 1 point, which test do I have to use for relative extremity?
First.
No, first derivative, I need multiple points to test before and after. Good idea, that is a test for relative extremity. What's the other one? Second derivative test. How do I use it? Second derivative test says if dy dx at the point is 0 or be any, then check the sign of the second derivative at the point. And given those two clues, I can make a conclusion. So if I plug in 0, negative 1 to the first derivative, is it 3x? Yeah, 3x over y equals 0. Hey, it's a critical number. Check. Now plug the point into the second derivative, which I think you guys found up above, right? 3 times negative 1 using the second derivative from up here. 3 times negative 1 minus 3 times 0 times 3 times 0 all over negative 1. That's all just 0. All over negative 1 squared equals, all I care about is the sign. What can I say from the second derivative test? Since the first derivative is 0 and the second derivative is negative.
Oh, it's a maximum.
Exactly. Since dy dx equals 0 and d squared y all over dx squared is less than 0, at h of 0 equals negative 1, h has a relative max at 0, negative 1. If you want to flesh this little clue out and say that indicates that h is concave down, at that point, you can. You can flesh this out. You can give more explanation if you want to. They don't need it, but you can. You can flesh this one out and say there's a critical number at 0, negative 1. You can do all of these things, kiddos. You can explain yourself, but all you really need is state that dy dx is 0. Well, it could have been d but 0 in this case. State that second derivative is 0 and be like, booyah, that's a max. Okay, real quick for FRQ number 3. Very similar problem. If you guys are struggling with how to draw your slope field, feel free to come ask. We can work on little baby tangents, but you tell me, what is letter B asking us to do? Find a particular solution. How do we always start? Don't lose your points. Multiply by dx. So I multiply by dx, I end up with, is it y? Yeah. Y cosine of pi x dx. Who does not belong? So divide the y away. Say nope, 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 you're on the wrong side. What do I do to both sides? Okay, great. Now that the y's are gone, now I can start getting points. I'm going quick just for sake of time. ln of y equals, oh no, I need q sub. Because I have an extra constant, that's going to make a difference. I can actually get dx to right. So I'm going to have 1 over pi integral of cosine of u du. What is the integral of cosine of u du? Positive or negative? Positive, good. Positive sine of u, which is pi x plus c. I'm stopping. I just integrated a lot. You should have gotten 2 to 3 points right now, if you got all this right. Question, what do I do next? Yeah, I can get y by itself. So I can do e to both sides, trying to get y by itself. I have this big old exponent, at which point I can go ahead and say absolute value of y is equal to c e to the 1 over pi u sine of pi x. Nice thing is the AP gives us way more room, huh? Plus your pencil probably writes better than my big chunky marker up here. Anyway, technically we could go ahead and kind of resolve the absolute value by saying c is going to be plus or minus depending on the domain of my point, or I should say the range. But question, what am I ultimately trying to find? Yeah, I'm not done until I use my initial condition. Good. Gotta use my clue. Gotta plug in the point 1, 2. So I get 2 is equal to c times e to the 1 over pi times sine of pi. Now guys, I have seen people say that you could technically not simplify sine of pi. I'm not sure I totally believe them on free response. For multiple choice, they make you know the unit circle. But I have seen people say that you can leave sine of pi, or sine of 2, or sine of 0, just to be safe. Since I know what sine of pi is. Sine of pi is equal to 0. 0 times anything is 0. E to the 0 is 1. Oh my goodness, c is equal to 2. Then I can go ahead and plug and chug right back into my expression that I had a second ago. Now knowing that c is 2. E to the 1 over pi sine of pi x. However, I do believe, based on what I have seen, that they would have also taken 2 over e to the 1 over pi sine of pi times e to the 1 over pi sine of pi x, if you are scared of your unit circle. Maybe it's better to leave it right instead of make it wrong. For multiple choice, you have to do a unit circle. For FRQs, you can pause. Sarah? Did you get your 1 over pi? Oh, this is the one you were verbally telling me. It would have been a little bit off. You need that 1 over pi in there. My brain was dead. I was just agreeing. But we almost got there. We just missed the 1 over pi. And last but not least, number C, guys, it's a forever card. What forever card for equation of a tangent line? Yeah, what is that forever card, everybody? Aaron, you are so distracted. Focus. Y minus? You got a point? Can't we just plug in the 2? Can't we plug in the 1? So what do we need here? The derivative, the dy dx, the f prime of x, however you want to talk about it, at the point 1, 2. The specific derivative at the point 1, 2. So whatever forever card says, we need the derivative. So, you guys have that thingy from up above. I don't even know, it's a messy thingy. Where is it? Y times cosine pi x. Oh, there it is. I see. So we can say y is 2 times cosine of pi times 1. And according to what I've seen, if you're not confident in the unit circle, stop there. If you are confident in the unit circle, hopefully you know cosine of pi is -1. Good. Dun, 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 dun. You don't have to solve for y. They just say find an equation of the tangent line. They don't say get y by itself like they do up here in this question. Okay, those pass this packet back over and in. I'll take it by the end of the day. You want to see how much area and volume you can get done? Why am I not scared to do lots of the odds with you? You can always do the evens and see if you really get it, right? Okay. And you have the answers to check. Guys, we have forever cards on the area between. We have forever cards on cross sections. We have forever cards on. Oh, there's more cross sections. They didn't talk about discs and washers. Come on. They leave it all out because they figure that you guys should know how to figure whatever. We have discs and washers. They're even better than the packet. Or even better than the packet. The whole team. Thank you, Jason. I appreciate that. Then. Question. As soon as we say area, we're not doing pi r squareds, we're not doing dishwashers, we're just saying area between. What do we think of? Yeah, we're just subtracting it, right? We're just doing this thing. Take one minus the other. But the problem is, how do we find the bounds if they don't tell us? Kinda. Basically find the zeros, it's find the intersections, right? Find the intersections when x minus 4 equals 0 or when x squared equals 4. They didn't tell us bounds, they didn't give us a picture, so we gotta find them ourselves. We gotta find the intersections. So then what does x end up equaling? Perfect, those are our bounds. The nice thing is, since these are the only intersections, how to handle integration with absolute value. You can pull it out as long as you have double checked there are no intersections between your bounds, and there are not. We're not visualizing, we're not even stressing, we're just saying whatever. One minus the other, check for the intersections, let's go. Help me out, kiddos. How do we solve a definite integral? Integrate. How do I integrate x squared? Power rule. How do I integrate 4? Technically power rule or constant rule. What do I do with my bounds? Which one goes first? The top one. Good. F of b minus f of a. So I have 1/3 times 2 cubed minus 4 times 2. That's f of b minus f of a. Plug in -2. 1/3 times -2 cubed minus 4 times -2. What should some of you be very careful about right now? Parentheses, multiplications, negatives, all that stuff. But what did we not add in from above? Yeah, so what do we still need to put? Absolute value on the outside of the whole thing. You solve the whole thing, then you make it positive. So now it's time to carefully simplify. We have 8 over 3 minus 8 minus -8 over 3 plus 8 absolute value. You guys know in the AP they give you tons of room, so use it wisely. I'm just going to keep going this direction for now. If you want, you can distribute your negative right now. If you notice, we're going to have an 8/3 plus an 8/3, which will be a 16/3. We're going to have a -8 plus a -8, which is -16. Guys, shouldn't you be able to say right now that's not going to be 0? It's not going to be a negative number. How do we finish this off? How do we combine these thingamabobs? Common denominator. Look at all the basic math you still have to remember. If you needed to do 2-column multiplication, you should end up with 48/3 16 thirds if you need to. 2-column subtraction. You get negative 32 thirds. So what is my correct answer? Now could some of you maybe, if you were just grasping at straws, see that only one answer is repeated with a positive and a negative, and maybe try to make a choice based on that? You never know. I wouldn't say that's necessarily the best technique, but it is a technique. Questions on that one? What question were we answering? Find the area between. We did not forget our absolute values, and we did not forget how to solve a definite integral along the way. Okay, where are we going? Number 3? Get the required ones. Ooh, graphing calculator. Go team. That means a lot less work for us, right? We can graph this thing. We can look at this thing. We can use our integration feature to be nice to us. Your calculator will go way faster than mine. Just in case something funny happens at the beginning of the AP, what mode are we going to make sure to be in for trig? Radian mode, for sure, for sure. I've been in like pre-cal stuff, so, oh, I'm in radians, never mind. Oh, but I'm in polar, that's awkward. BC has polar, you guys don't. Okay. I want to graph, not that. E to the sine of x, use your calculator for everything. You don't have to do it. And then we have sine of x. And then we have 2. And then why am I going to make my window just from 0 to pi? Well, actually, let's start with zoom standard first. Then let's go 0 to pi. Why am I doing that? Good. It's the interval. I only want to see that part. Ew. That's gnarly. What am I seeing? Are you guys seeing what I'm seeing? How many intersections do we got? Oh, we got 2 of them. Stink-a-dink. So we have to go ahead and, wait, hold on. If we were solving by hand, we would have to find these intersections, and we would have to do the whole absolute value thing and find one integral from here to here, absolute value, one integral, absolute value, absolute value, one integral from here to here, absolute value, one integral from here to here. Since we can look at a graph, we can actually figure out top, bottom for each. But wait, can't we use our calculator? Does our calculator know how to do absolute value? So couldn't we put in our calculator absolute value and it would do it for us? Without us having to bring the absolute value out? We only have to bring the absolute value out and worry about intersections. If we can't use our calculator, we have to do it by hand. Otherwise, maybe we could just go ahead and use math function integrate. 0 to pi and say, oh, Mr. Calculator, I'm so glad you know how to do absolute value. Because you can go to math and you can go to over and you can say, hi, absolute value. You're my hero today. So I have e to the sine of x minus 2 dx. Oh, what stink. It didn't go fast enough. My brain worked faster than my cursor. There we go. dx. The correct answer is C. Guess what? It's exactly the correct answer, and we didn't have to do any of that crazy splitting up of the intersections, Jazz. We could have. We could have made it much longer and did half of it by hand, or we could just say, I'll throw the absolute value bars in and make the calculator do all the work. Done. Done. Go team. Uh-oh. What's going on in number 5? But, It's a non-graphing calculator, so praise the Lord that we should know what absolute value of x looks like. Right?
Yes.
And from 0 to 1, 2, 3, and 4. And we can know without the graphing calculator, without doing some crazy table or something, that since we are revolving it just about the x-axis, this is going to be a disk or a washer. Yeah, it's a disk. It's flush against. There is no hollow space. So why am I drawing this representative line? I'm drawing it for my radius. To say this is a simple in regards to knowing our forever cards and knowing disks, by the integral from lower bound to upper bound of who squared dx, because it's about a horizontal axis. R, and who is R? Top minus bottom. And who's on top? And who's on bottom? So we're awesome, and we know minus 0 just means poof, he's gone. We're also awesome and hopefully know that the square root of x squared is just x. And now, sadly, it is our time to solve this definite integral. But don't be scared, you guys got this. 1/2 x squared from 0 to 4 times pi. There's a lot of brackets, I don't know why. Don't judge. Then we can go ahead and plug in 4 over 2. Nope, sorry. 1/2 4 squared is 16. Minus 1/2 0 squared is 0. We end up with, beware the big jumps in your mental math. They might lead you wrong. You guys agree with me?
Yes.
Okay, fuzzy brain didn't mess it up. Okay, good. So my brain, more like my head. Let's see. Okay, where are we at? Yay, go team! We like these. What do we do with it? Go get that graph. Wait a minute. How do I think about the x-axis? What does y equal? Isn't it just 0? Oh, sweet. Am I going to make my window?
-5.
Stink. Oh, wait, that's not bad. Top, bottom. Wait. Doesn't this not even matter? What did I just teach you? That you don't need the graph for when using your graphing calculator and area between. Can't you just throw the absolute value in and say, who cares? Mr. Calculator, do it for me, please. Now, on this one, the absolute value is not going to make any difference because as you guys noticed, nothing switched orientation. This guy is always on top as you look at it. This guy is always on bottom. Just trying to show you for harder examples, all we got to do is throw the absolute value in and go, go, go. Some of you realize minus 0 doesn't make a difference anyway, but we still need that absolute value in. We can go math, we can go number 9. If you guys remember, there is an alpha y equals shortcut to these. Wait, where am I going? Where's the integral? Oh, there he is. Number 4, but that's just if it's shorter. I don't know if it is. We have our negative pi to pi. We could use some even symmetry and go like between 0 and pi and double it, but we'll just do it the old school way. Technically, to be safe, I just totally failed in that I told you guys absolute value and did not model it because I knew what the graph looked like. But just to be safe, if you didn't know what the graph looked like, you would go ahead and put the absolute value in. We love our fail-safe. Final answer is C again. Yes, don't just guess C because there's a couple of them in the packet. Number 9. We're on a roll today, guys. Oh, stink. We have another revolved one. It's not a graphing calculator problem. So we kind of have to know our basic graphs. Except this one's not quite just an x cubed question. What difference does an x plus 1 on the inside make? You shift 1 to the... something like that. It's an x cubed, but shifted 1 to the left. What do we have? Like x equals 7? Just make that randomly 7, even though that's a negative 1. Whatever. And it's being revolved where? Hey guys, look at it. Is it flush? Is it a disc or a washer? It's a disc. Aren't we just going to use 5? Hard, square. Alright, cool kids. You know what to do. Odds. Required. Evens. Bonus. You guys can probably finish this one, yeah? Alright, cool kids, I will see you later. Remember, I won't really be in here available for questions during 7th grade, but I should be after school, and I'll see you guys later. There's only one more multiple choice. Go team. 2 at Berkey's.